Hello guys, in this video we are doing electrolysis. Let's start by defining electrolysis. Electrolysis is the decomposition of electrolyte into its ions by the use of electricity. So this means if you don't have electricity, then there is no electrolysis that is going to take place. Let's see the terms that are used in electrolysis. Number one, electrolyte. Electrolyte is an ionic compound that conducts electricity. Examples include acids and bases, such as sulfuric acid, sodium hydroxide, sodium chloride. During electrolysis, the electrolyte is broken down into its ions. For example, sodium chloride is broken down into sodium ions and chloride ions. Sulfuric acid H2SO4 is broken down into H plus ions plus the sulfate ions. Electrolyte must allow free movement of ions. Electrolyte must allow free movement of ions. This means electrolyte must be in liquid or the solution state. Term number 2, electrode. An electrode is a solid substance that provides the contact between the power source and the electrolyte. Number 3, anode is the positive electrode to which negative ions are attracted. Number 4, cathode is the negative electrode to which positive ions are attracted. Number 5, cations. These are positive ions. For example, copper 2 plus, sodium plus, magnesium 2 plus. Number 6, anions. These are negative ions. For example, chloride ions, fluoride ions. Electrodes are commonly made of unreactive material such as platinum, carbon. The carbon used is in form of graphite. Electrodes that are made of unreactive material are called inert electrodes, and we can define it as the electrodes that do not participate in the chemical processes in the electrochemical cell. Electrolysis setup. The electrolysis setup is known as the electrolytic cell. So we have a cell connected here. It's either a cell or a battery with a positive and a negative terminal. Then this side we find our positive electrode, which is the anode. And this side, the negative side, we have our negative electrode, which is the cathode. Negative, this one is positive. Then we have the electrolyte. The electrolyte is either it is in molten state or in the aqueous solution. Inside the electrolytes, that's when we have the ions. So we have positive ions and negative ions. And negative ions are attracted to the anode. The positive are attracted to the cathode. So let's see what is happening during the process of electrolysis. During electrolysis, positive ions are attracted to the negative electrode, where they gain electrons to become atoms. This process is known as reduction. This means the cations are reduced to atoms. For example, let's have sodium plus is a cation and it gains an electron, then it becomes sodium. So we have reduced a sodium ion into sodium atom. So this is the process of reduction. Let's see what happens to negative ions. Negative ions are attracted to the positive electrode, where they lose electrons to become atoms. So this means the anions are oxidized to atoms. For example, chloride ions. Chloride ions are going to lose electrons to form chlorine molecules, plus an electron loss, but we have to balance the equation. So we need 2 chloride atoms, then this side we need 2 electrons. Chloride ions are in aqueous state, then chlorine atom is in gaseous state. So the process that takes place here is the oxidation. The flow of electrons is from negative terminal to the positive terminal. So this is electron flow. Then this one is our negative electrode. So the process which is going to take place there is the reduction, where there is gaining of electrons. The process taking place at the positive electrode is oxidation, where the electrons are being lost. You can see that during this electrolysis process, both the oxidation and reduction are taking place at the same time. Therefore, the electrolysis reaction is regarded as a redox reaction. So let's note it down. In electrolysis, both oxidation and reduction take place at the same time. Therefore, electrolysis is a redox reaction. What is a redox reaction? Redox reaction is a chemical process by which oxidation and reduction take place simultaneously.